Okay, so let's look at this next theorem. Theorem 6 says, let f and g be continuous functions with f of x greater than or equal to g of x over an interval ab. So let me stop there a second before we keep reading, because sometimes it's a challenge to read an entire theorem in one shot without understanding each little piece. So first off, f and g need to be continuous functions, right? So it can't be any breaks, any open holes, nothing. F of x is greater than g of x, or equal to. So I've drawn an f of x on the graph over here. I've drawn a g of x over here. F of x greater than or equal to g of x simply means that the f of x is higher than the g of x function. Got it? Okay. And it's over an interval from a to b. So notice your a and your b are x's, aren't they? Because they're on the x-axis. Agreed? All right. Then the area of the region between the two curves. So here's the area of the region between the two curves. From x equaling a to x equaling b is given by, I am going to take the integral from a to b, because those are my x's. And in order to find that region between the two curves, I'm going to subtract. I'm going to take the original function, which is f of x, and I'm going to subtract the g of x function. And you're like, I kind of don't get that. All right, so let me do a little bit of erasing here, and hopefully this will make a little bit more sense. You're like, why are you subtracting? Here's why I'm subtracting. If I take the integral of f of x, that will give me the area from the x-axis to f of x, right? So that means it would be this entire interval, this entire region, I should say, under f of x. So it would be from under f of x to the x-axis. That would be this whole region, right? If I take the integral of g of x, that would be from the g of x curve to the x-axis. That would be this entire region, right? Okay. But I only want what's between there. So to get what's between there, I'm going to take the entire f of x and subtract this g of x, and the leftover is what's between the two curves. Make sense? Okay, good. So we're going to put this into practice, and I need to get a problem up. So hang in there. Okay. They've given me this graph, and we need to find the area of the shaded region. I know, this is a lovely looking graph, isn't it? They've given me two functions. The curve function is f of x, which is a third degree polynomial, x cubed plus 3x squared minus 9x minus 12. The linear function is being represented by g of x, which is equal to 4x plus 3. Okay? All right. Now, if we notice from the x's, I should say we have 3 points of intersection. We have negative 5, comma, negative 17. I forgot negative in front of there. We have another point of intersection of negative 1, negative 1. And we have another point of intersection from 3 at 315. If we notice, the f of x function is higher than the g of x function at this particular interval where x is equal from negative 5 to negative 1. Agreed? And on this other interval, I'm noticing that g of x is higher than f of x. And that's from x being equal to negative 1 and x being equal to a positive 3. Agreed? Okay. So I think it's important to write that information down. From negative 5 to negative 1, which function did we say was higher? Yeah, the f of x function is higher greater than or equal to the g of x function. But on the next interval, which started at -1 and ended at +3 for your x's, we noticed that the g of x function was higher, greater than or equal to the f of x function. Right? Okay. That's going to be very important for us. Now, we need to set up how we're going to find the shaded region for the graph that they've given us. All right? This problem, I'm going to tell you right now, you're going to have to take it slow because there's a lot going on here. It's not challenging, but there's a lot of algebra that's going to happen here that we could easily make a mistake on. All right? So if you just want to put your pencils down for right now and just kind of watch for a little bit, rewind, totally your choice. So here's how we're going to find the area between these two graphs. My first interval from -5 to -1. I'm going to take the integral from -5 to -1. Now, f of x was greater than or equal to g of x, right? Which means I am going to take f of x and I'm going to subtract g of x dx in order to find that area. Then I'm going to add to it the integral from -1 to 3 because that was the next section of the shading. But on this particular interval, g of x was higher than f of x. So I'm going to do g of x minus f of x dx. With me? Okay. So let's look at the first one. The first integral from -1 to -5. I'm going to take f of x, which is x cubed plus 3x squared minus 9x minus 12. And I'm going to subtract g of x. When I subtract 4x plus 3, won't that just be minus 4x minus 3? Is that agreed? Because all the signs will change when you subtract g of x, correct? Okay. Now, the second integral is from -1 to 3, and the g of x is coming first on that one. So now we have 4x plus 3, and we're going to be subtracting f of x. So when we subtract f of x, won't all the signs of f of x change? Good. So that means it's going to be minus x to the third minus 9x squared, 9x squared, listen to me, minus 3x squared. See what I mean? That's why it's good for us to work these problems together. Plus 9x plus 12 dx. Agreed? Okay. So let's start collecting some like terms. On the first integral from -5 to -1, I'm going to have x to the third plus 3x squared, and I can collect the -9x and the -4x, which is -13x, and the -12 and -3 will give me a -15 dx. Right? Right. On the second integral from -1 to 3, I'm going to put this in descending order as I collect like terms. So what comes first? Good, the -x to the third. What's next? Minus 3x squared. And now I'm going to collect those x's. So 4x plus 9x. A positive 13x, a positive 3, and a positive 12 is a positive 15. Right? dx. Are you agreeing? Good. Now that I've got my two integrals established with the polynomials collected, now I can take the antiderivative of these. And some of you are going, wait. I noticed that the polynomials have the same terms but the opposite signs. Cool. Hopefully that'll help us. especially when we come up with the antiderivatives of each one, right? Okay, so no surprise, I need some board space. All right, got some more board space. So I've written how to find the area by the addition of the two integrals. And now we have to antidifferentiate. Yes? Okay. So the first integral from -5 to -1, when we take the antiderivative, we're going to get 1/4 x to the 4th, good, plus x cubed, good, minus 13 over 2x squared minus 15x. And we're going to evaluate it from -5 to -1. Excellent. Now, by the way, if you need to pause the video and take the anti-differentiation slowly, then please make certain you do that. So I would suggest rewinding it, pausing the video, and taking the antiderivative of that third degree polynomial and see if you get the same thing I did right there. Okay. The second part, gratefully, since I know the first one, the second one should be easy, correct? So this would be a -1/4 x to the third. How about we try that again? -1/4 x to the power of 4. See what I mean? Gotta take this thing slow. Minus x cubed plus 13 over 2x squared plus 15x. And I am going to evaluate this one from -1 to 3. So I'm just going to do a quick check. If I take the derivative of it, I'll get x cubed, 3x squared, 13x, and a 15. Good. Cool? All right. Now, this is where we really need to take it slow because we're going to be plugging in the -1, subtracting whatever we get when we plug in the -5, and on the second part, plug in the 3, subtract whatever we get for the negative. We just got to be careful on this. All right, so we're going to take it slow. So I'm going to plug in the -1 first. So -1 to the power of 4, gratefully that's a positive one. So 1/4. -1 to the power of 3 is a -1, so that's going to be -1. -1 to the power of 2 is a positive 1, so that's still going to be minus 13 over 2. -1 times a -15 will give me a positive 15, right? And then I'm going to subtract when I plug in the -5. Agreed? All right. So -5 to the power of 4. What do you guys get? Good. 625. So that's going to be 625 over 4, isn't it? All right. -5 to the power of 3. Yeah, that's a -125. -5 to the power of 2. Well, that's a positive 25. So now I have a positive 25 times -13 over 2. And I've got my handy dandy cheat sheet. Hopefully you and I will be agreeing. But I get a -325 over 2. Did you? Cool. And then -5 times a -15 gives me a positive 75. Okay, so there's that first part, isn't it? All right. I wish the other part had the same numbers, but they don't, except for the -1. I'm going to have to plug in that 3. So, plus, and plug in that 3. What's 3 to the power of 4? 81 times a -1/4, -81 over 4. What's 3 to the third? 27, so minus 27. 3 squared, that's 9. And now I have to do 9 times 13 over 2. I got positive 117 over 2. And then 3 times 15, plus 45. And then I've got a minus from it, and I'm going to write it underneath. plugging in that negative 1. So what's negative 1 to the power of 4? Positive 1, so that's a negative 1/4. Negative 1 to the power of 3 is a negative 1. So that's a positive 1, isn't it? So you're minusing a negative 1, right? Negative 1 squared, positive 1, so that's a positive 13 over 2. And then negative 1 times a positive 15. Negative 15. Okay. Y'all with me on this? Yeah, we really have to take this slow here because we need to just make certain that we're okay in terms of our algebra. Okay. So I'm going to look at this first parenthesis. And I'm noticing that I can add the negative 1 and the 15, which will give me what? That'll give me 14. And I still have, what, the positive 1/4? And now, 13 over 2. Couldn't I change that to a denominator of 4, so at least I have a common denominator with the 1/4? Good. So 13 over 2, to make it a denominator of 4, what are you going to have to do? Multiply top and bottom by 2, which will give us 26 over 4. Good. You all right with that? Okay. Minus, now I'm looking at the second parenthesis, and I can quickly add the negative 125 and the positive 75. What will that give us? Good, that'll give us a negative 50. And I notice the positive 625 over 4. And I can change the negative 325 over 2. I can change that to a common denominator of 4 as well, can't I? Doing what? Multiplying top and bottom by 2, which will give us 650 over 4. Good. Okay? Okay. Now, plus, let's look at this second half. In the first parenthesis, I'm noticing that I can take a negative 27 and add it to the 45 very quickly. What will that give you? 18. And then I have minus 81 over 4. Notice the 117 over 2. What are you going to do? Good. Multiply top and bottom by 2 so I can have a common denominator of 4, which will give you 234 over 4. I'm going to draw us a little dividing line here because I'm running into that work, which I don't want it to mess us up. Minus. Let's look at this last parenthesis. I'm noticing the positive 1 and the negative 15. Good, that's a negative 14. Minus 1/4. What are you going to do with the 13 over 2? Yes, I'm going to multiply top and bottom by 2 so I can have a denominator of 4, so that becomes 26 over 4. Are we okay so far? All right. Take this slow. You see how easy it could be to mess up, right? Okay. So, back to that first one. In that first parenthesis, you're going to have 14. And now I have a positive 1/4 minus 26 over 4. Good. That's minus 25 over 4. Minus. I have a negative 50 in that second parenthesis. Do you notice the positive 625 over 4? Minus 650 over 4. What do you get? Good. Minus 25 over 4 plus. Now we're going to deal with that second part, right? In that first parenthesis, there's an 18. So now I have negative 81 over 4 plus 234 over 4. So yes, positive number, what do you get? What is that? 153 over 4. Do we agree? 4. Good. Minus. Look at the next part. You've got that negative 14. Negative 1/4 plus 26 over 4. Yeah, plus 25 over 4. How are we doing? So far, so good? All right. Now, I know, right? Let's just take this slow. I'm just going to start distributing the subtraction signs, And hopefully some of this stuff will easily add together. Maybe some of it will even cancel, especially on the fractions. Let's just take a look. So we have 14 minus 25 over 4. Distribute the negative sign to the negative 50 plus 50. The negative sign to the negative 25 over 4 plus 25 over 4. Oh my goodness gracious, I'm seeing those two fractions cancel. Yay! Okay, plus. Let's get to that second half. That's that plus sign, in case some of you got a little bit lost. 18 plus 153 over 4 minus a negative 14 plus 14 minus 25 over 4, right? Okay. So right away we see this negative 25 over 4 and this positive 25 over 4 cancel, don't we? And I'm noticing 14 plus 50. Well, there's 64, so yay for that. Plus 18 plus 14, so that looks like plus 32. 153 over 4 minus 25 over 4. What do you get? Good, positive 128 over 4, right? Does 128 over 4 reduce? What was it? Oh, that's a nice number. So I've got 64 plus 32 plus 32. Woohoo! 128, which is what I got when I did my work. Yay! Well, wasn't this a nice problem that they first gave us to work on? My goodness. Okay. All of this was our algebra. The previous, however many minutes ago now, was us setting up the integrals to find the area of between the two functions. So this part of the video was working out all the algebra. The previous part was the important part of setting it up. And if we didn't set it up correctly, we wouldn't have taken the antiderivative correctly. Good? Okay. So I got another one of these problems. I promise it's not as bad, so stay tuned. Notice the directions. Find the area of the region bounded by the graphs of the given equations. Now, you know, the last problem may have been very involved algebraically, but at least in the last problem, they actually gave me the graphs. This one, they didn't. So they need me to find the area of the region bounded by these two graphs. So what do you think we're going to have to do first? Yeah, we need to graph it, because in order to figure out the area, I need the integral, correct? But I don't know which one of these is higher than the other one. So we need to graph this. Now, when we graph it, the y equals x is a very easy equation for us to graph. That's just where y equals x. So you plug in 1, you get 1. You plug in 2, you get 2. Plug in 3, get 3, etc. Right? Plug in -1, you get -1. So this will be our y equals x. Now, yes, I have graphed these already, so I know what they look like. 6x minus x squared. That is a parabola facing down, isn't it? If I plug in 0, I get 0, don't I? And if I plug in 1, 2, 3, 4, etc. Now, based upon my graph, and some of you may actually be graphing these on the graphing calculator, and that's fine. But based upon my graphing of this 6x minus x squared, I get a parabola facing down, and I'm noticing that the parabola facing down intersects the y equals x at the point 0, 0 and at the point 5, 5. Well, that was convenient, wasn't it? With me? Okay, so this is y equals 6x minus x squared. And they'd like me to find, just making sure it was 5, 5, they'd like me to find the area that's bounded by these two graphs. So here is the area that they would like me to find. So to find the area between the two graphs, we're going to take the what? We're going to take the integral. The integral is going to go from where to where? Yes, x being 0 and x being 5. Because that's the 2 points of intersection, right? Again, this problem seems a lot simpler than the last one, but at least the last one they actually gave me the graph. Anyway, now, which one of these functions is higher? Yes, the 6x minus x squared is actually higher than the x. So that means you are going to write the 6x minus x squared first, and you're going to subtract from it the x, right? Okay, and then dx. Agreed? Good. If you don't get the setup right, then doing the computation doesn't matter. Do you agree that the parabola is higher, graphically speaking, than the y equals x, the linear function? All right, just checking. So when I simplify the subtraction of the two functions, I end up with, and I'm just going to write it in descending order, we end up with a negative x squared plus 5x, don't we? Right? Okay, now let's take the antiderivative. So, you guys are really good with your antiderivatives at this point. Let's just walk through it. So negative 1/3 x cubed plus 5 over 2x squared, and that is going to be evaluated at 0 to 5, right? All right. Fractions. Lovely. But gratefully, one of these that we're plugging in is a 0, so that's going to make life nice for us. All right, so let's bring the work over here because I have more room. Plug in the 5. What's 5 to the third? 125. 125 times a negative 3, negative 1/3, excuse me. So we have negative 125 over 3 plus 5 squared, 25, times 5 over 2. Plus 125 over 2. And when you plug in 0, it's just all going to be 0, so I don't even have to, I can write it minus 0, but that's not going to do anything. Agreed? Okay. Two fractions, denominators are not the same. Need to make them the same. What are you going to do? Yes, you are going to get a common denominator of 6. So the first fraction, top and bottom by 2. Second fraction, top and bottom by 3. Looks like negative 250 over 6 plus 375 over 6, which gives us positive 125 over 6. By the way, if I have a negative area, something's wrong, don't you think? Cool. Can I reduce that? No. If they want a fraction, there it is. If they want a mixed number, then we're going to give them 20 and 5 over 6. So be careful of the directions. What do they want? Do they want the fraction or do they want a mixed number? Good? Okay. Again, this problem was a lot simpler in its computation, but I had to go do my graphing and find the 2 points of intersection so I could figure out the actual integral. I have a definition for us. So get ready to write down a new definition. Let's look at this definition. Let f be a continuous function over ab. And it's a closed interval, right? Because there's brackets. Its average value, that's what we're trying to define. Its average value, and it's represented by 1, and the subscript is av for average value, over the interval ab is given by. So to find the average value, you're going to take 1 over b minus a. So the larger x minus the smaller x, multiply it by the integral from a to b of the function itself. Good? So you know when we average things together, you add things up and you divide by how many you added up, right? So if you think about this definition, b minus a kind of gives you that number of items that you're adding up, right? And when you add things together, well, that's going to be represented by taking that integral. So just to kind of try to translate it a little bit, when we average, we add things together, which is basically going to be this integral, over how many we added up. Well, that's basically going to be this b minus a, 1 over b minus a. Cool? Okay. Because this is the area of the graph, and we're dividing by how many things we're adding up. All right, so they're giving us this example. They're asking us to find the average value of the function 4 minus x squared over the interval from -2 to +2. It's closed. First off, I need to make sure my function is continuous. Is 4 minus x squared continuous? Yeah, that's an upside down parabola. Definitely continuous, no breaks there. Cool? All right, so based upon our definition up here, how do we find our average value? 1 over b minus a. So don't get too bogged down in b minus a. It's the larger x minus the smaller x. So 2 minus a -2, right? Multiplied by the integral of -2 to +2 of the function, which in this case is 4 minus x squared dx. Cool? All right, let's do our computation. So this is 1/4, and we're multiplying it by antiderivative of 4x, antiderivative of x squared minus 1/3 x cubed, and you're going to take that parenthesis and you're going to evaluate it from -2 to +2, right? Okay, so this 1/4 is just going to hang out here a little bit. And now I need to figure out this evaluation. So you plug in the 2 first, agreed? So what is that? 8 minus, what's 2 to the third? 8 times 1/3. Good, so minus 8/3. And I'm going to subtract from it. So we plug in the -2. Good, first number is a -8. Good, plus 8/3, right? Okay, so let's take our work up over here because I have more space. The 1/4 is still here, right? And in the brackets, I'm just going to distribute this minus sign. I want to see what happens. Maybe I still have to add fractions. Maybe they cancel. We'll find out. So we have 8 minus 8/3. Distribute the subtraction sign. Gives me a +8. Distribute. Gives me a minus 8/3. Oh, it doesn't look like anything's canceling. That's okay. We can handle it. Okay, so our average value is going to be 1/4. And in these brackets, looks like 16 minus 16 over 3. Agreed? Okay, I'm going to need a common denominator in those brackets. Yeah, we're going to have a common denominator of 3, which means the 16 over 1, multiply top and bottom by 3. I agree. So it looks like we have 1/4, and in those brackets. Good, that's going to be 48/3 minus 16/3. What do you get when you subtract those two fractions? 32 over 3. Okay, I agree with you on that. And now I'm taking 1/4 times 32 over 3. So my average value, yay, the 4 and the 32 cancel. Looks like my average value is 8/3. Or if they want a mixed number, 2 and 2/3. With me? So the average value is not so bad to find. It's taking the integral, which we've been doing, but it's just multiplying by the 1 over b minus a. Good? Okay, we're at the end of this lecture. Hopefully you had fun, and I'll catch you on the flip side.